Hello, everyone. Thanks for being here today. My name is Joyce Zandee, and I am the product owner of the Send Explorer product family at Certara. I am a biostatistician by training, and the bulk of my career has been spent in environments where I'm working side by side with toxicologists and study directors, clinical pathologists, and various drug development team members. So I have been able to experience firsthand the challenges that these scientists face when they are reviewing vast amounts of study data and trying to use these learnings to be able to communicate salient study findings to their drug development team members and, of course, to regulators. So Send Explorer is a product that we've developed with those kind of problems in mind. This visualization tool reads Send data sets, non-clinical study data, including Send data sets, but also other non-Send formats as well. It reads the data into a data warehouse that has been optimized for querying and visualizing the data. And then Send Explorer helps those non-clinical scientists visualize the study data within a study or across multiple studies to help them understand what's going on in the study and to be able to tell the story to their peers, their scientific peers, and also to regulators as far as what's going on with the study and with the program. So today I'm hoping to share some of the findings that I've learned, the learnings that I have gathered over the years, more than 30 years of industry experience regarding what makes effective visualizations of non-clinical data, what features help ensure that the display focuses on relationships that are important in drug development. And I've done this by preparing a number of questions that you can use to assess the effectiveness of your current visualizations or your current visualization tools, or some questions that you may want to use when you are choosing a new visualization tool. So please note that these questions are worthwhile to consider irrespective of what tool was used to create the visualization. So it can be products like Spotfire or Tableau, or it can be Excel or SAS, or some custom purpose-built visualization tool like Send Explorer. It can be any one of those. So I'm not focusing on any individual visualization and putting in any individual application and putting these questions together, but these can be applied to any sort of visualizations that have been created. They don't address any technical or operational aspect of using the application. It doesn't look at the ease of maintenance or how much it costs or what is the validation status or any kind of effort to integrate with other products that you have in your organization. But they're purely focused on the effectiveness of the visualization and conveying meaningful relationships in drug development. All right. So we're going to look at the types of questions we may want to ask ourselves when we're looking at assessing these visualizations of non-clinical study data. So first and foremost, we want to be able to pick up on scientifically relevant patterns and trends. Does the visualization allow you to detect dose response relationships at a given time point or across time? Can I follow the time course pattern of group summary values over time? Does it help highlight these relationships that you are most interested in, or does it actually obscure them? Now, for non-clinical data, there's many different types of endpoints that we're interested in detecting dose-response relationships and at multiple time points during the course of the study. So can we look at one study at a time point? Can we look at multiple time points? Can we look at individual subjects that may be outliers? And if we do see subjects that are outliers, is it possible to temporarily suppress those outliers so that we can see what the impact would have been if that subject had not been there? Or can we drill down on that outlier to get more information about that particular subject? Can you delve into the details of those individual outlier subjects? Is it possible to compare individual subjects within the group and also across groups? Can I compare subjects in the high dose group with the subjects in the control group? And can I look at one time point, that comparison within one time point, but can I also look at that across time? When it's appropriate, do I have the ability to look at more than one endpoint or data type? Can I look at body weight and food consumption together? Can I look at histopathology data adjacently to lab measures? Can I look at those side by side? Can I correlate those two? So where it is appropriate, do I have options to look at more than one endpoint or type of data at a time? All right, the next set of questions that you want to ask yourself are revolving around whether or not your visualization puts findings into the appropriate context. And what I mean by that is when you're trying to go across plots, are the X and Y axes aligned appropriately so that those cross plot comparisons are meaningful? If you have different time scales, for example, or if you have different magnitude scales for a particular endpoint and you're looking across studies, then it makes it really hard to understand the nuances and the differences amongst those. There are other cases where it really is okay to have different axes. For example, if you're looking at an endpoint that has an order of magnitude difference between the rats and the dogs, then you wouldn't want to force the same scale on a comparison between those two species, because a dose response relationship may be completely obscured if you do force the same y-axis. So this is important in your visualization. Do you have the ability to force the same scaling, or do you also have the ability to allow the scaling to be data driven? You would like to be able to have both of those covered. Furthermore, if you're looking at counts of findings, it's really important to be able to assess the number of subjects or the number of tissues that were examined. So you don't want to just look at the counts. You want to be able to put it into context as to how many were examined. And if there are differences in those counts, can you adjust for that when you're looking across studies? For example, can you convert it to a percentage instead of just looking at counts? If the number of subjects is different between the studies, then you want to be able to make an adjustment for those differences. Something else to point out is that when you're looking at character-based descriptive values, you want to be able to sort those values in a meaningful way. For example, in severity, if the scaling was minimal, mild, moderate, marked, and severe, you wouldn't want to sort those alphabetically because that would be a nonsensical order for your severity. Or for example, if we're looking at disposition status, interim, recovery, terminal, that's alphabetical arrangement of the disposition statuses, but it is not a sensical order that you would want to see those in. Or the group labels, you would want to make sure that the control, low, mid, high dose group are in an order that makes sense, not an alphabetical order. Another thing to think about is whether or not it's possible to see individual subject data in the same context as the group summary data. So what you don't want to do is toggle between different scales when you're looking at individual subject data and group summary data without being aware of the change of the scaling, because you're trying to look at individual subject data and see if it's highly influencing the group summary value. So you don't want to miss out on that by changing your scaling as you go from subject to group summary values. Furthermore, keep in mind when you're looking at context, are the methods that are being used assuming normality? If the visualization is using z-scores or reference ranges, are they non-parametric? Are they assuming some parametric distribution when it may not be appropriate? Another set of questions deal with the granularity that you can review your data. So you want to look at summary measures for sure, and you want to look at that across groups. You want to look at that across time. You want to look at dose response relationships, but you also want to look at more granular level data, at individual subject data. So from the group, can you drill down and look at individual subjects? And from those individual subjects, can you get more detail about those subjects beyond the measure that you're currently looking at? So can I look at not only a lab measure, but can I look at what's going on in the body weight and the food consumption and the clinical observations for that subject? what was happening to that subject in as far as organ weights go, as far as findings in the macroscopic and microscopic domains. So you want to be able to look at additional subject details when you drill down on those subjects. Furthermore, in any of your visualizations, you should be able to generate a raw data listing for the data that was used. So you don't want to just rely on the visualization, look at a summary depiction, and then not have any way to actually confirm the data. So especially if something looks a little bit off, you may want to review the raw data. So always make sure that you can easily get from a visualization to the raw data that comprises that visualization. If it's appropriate, you may want to combine data across studies. For example, we have a case where we want to look at SDH values versus the severity of necrosis findings in the liver. And you want to look at rat studies, irrespective of what their dose level was, irrespective of what treatment. You're trying to correlate SDH to the severity of necrosis in the liver. So you want to combine across studies where it makes sense to do so. You don't necessarily want to always split it up by study. Or if you're trying to look at control data, it may be appropriate to combine across studies when you have the ability to combine them across studies or split them apart by study. That is ideal. Further here, we say, can I easily navigate from multi-study data to review the findings in the individual studies and in the associated subjects? So I want to be able to look at the big picture across studies, but I also want to be able to drill into what's happening one study at a time and also in the individual subjects. All right, I'd like to share a word of caution before we proceed any further about using pie charts, because personally, I have not found pie charts to be the optimal visualization for communicating dose response related patterns or time trends. So I've seen some very fancy pie charts and their first cousins, the donut plots, or their second cousins, more distant relatives, the tree maps, that really rely on the user's ability to distinguish differences in areas. So to depict changes that are going on in the data, you have to really see the difference in the size of a slice of a pie or an area of a tree map. You have to be able to depict changes in areas. These plots are often very visually appealing, and sometimes they're interactive and allow you to drill into the individual pie slices to get more detail. But I do recommend that these plots be highly scrutinized to make sure that they reveal the type of patterns and trends that you're really interested in detecting, like dose response or changes over time. And outliers. That's another thing that you want to make sure that your pie chart is able to pick up on outliers. The fundamental issue with pie charts is that people tend to be better at comparing lengths and heights that you can see as in a bar chart or in a line graph than at comparing angles and areas within a pie, especially if there are many pieces of the pie. And the rule of thumb is if there's more than greater than or equal to 5 pieces of the pie, or if you're trying to compare multiple pie charts, then it's really hard to compare across those and to really read and interpret them. Oftentimes when you have lots of skinny pieces of the pie, they all have to be labeled separately. And then instead of just trying to get a sense as to what's going on by look at the pie chart, you have to read the labels around them. And you have to, if you're going between pie charts, you have to make sure that the angles are lined up so that you get a sense of what the difference is on the slices of the pies. It's also hard to detect differences in slices of the pie when they're not adjacent. So if we have 2 different slices that are on separate sides of the pie, it really makes it hard to compare the sizes of those two. If there is a dose response effect that has a low frequency finding, it may show up in a really skinny slice of the pie and you may overlook it altogether. So that's another shortcoming of pie charts, is that if it's a low frequency finding, it may not even be bubbled up to the top. You may not even pick up on it. I found that pie charts are poor vehicles for comparing different data sets. So if you have 2 different studies and you're trying to look at particular findings across those 2 studies and they each have their own pie, it's really hard to compare those. When the angles don't align, it just really makes it hard. And they're also very hard to communicate changes over time. So if I'm trying to look at a pattern that changes in a body weight over time, for example, really hard to see that on a pie chart. So when your visualizations for your tools include pie charts, give them a little bit of extra scrutiny and make sure that they are able to highlight the relationships that you are interested in and understand where they are very good at depicting changes. So know what its benefits are and also know where its shortcomings are. All right, so we're going to do a little bit of a pivot now, and we're going to examine some of the purpose-built data visualizations within Send Explorer and see how those concepts that we were talking about earlier have been applied in the case of these visualizations. So we're going to ask those same kind of questions of those visualizations that we've created for Send Explorer. This first page has actually two different views. Both are called scatterplot time course views. And in the visualization, we take a single endpoint. In this case, it is RDW. And I've got two different studies, a rat study and a dog study. And in this top view, I'm looking at distinct time points on which RDW was collected for this, the top study, the rat study, day 29, 36, and 57. And I'm looking at a dose response relationship within each one of those study days. So I have control, low, mid, and high dose groups. Those data points are next to each other so I can focus on a dose response relationship. And then right next to that plot, right below it, I have the dog study for the same compound. It's the same duration, but I can also line up the days where there's a match. So day 29, 36, and 57, a line between these two studies. And again, I can focus on whether or not there's a dose response relationship at each one of these days that matches between those studies. And I can see what happened at other times during the study as well. What's nice about this view is that I get a box and whisker plot for each one of these dose levels. I get a box and whisker plot that is showing the summary data. So what is the mean value? What's the median and the min and the max? I can see if there's any individual dots as well. The summary measure is the box and whisker, and the individual subjects are the color-coded circles and diamonds to the right of the box and whisker. The circles are for males and the triangles are females, so I can also compare between sexes in this same visualization. Another thing that's nice here is that it allows me to focus on that dose response trend. But if I want to see what was happening over time, I can flip a toggle switch on this visualization and this plot and the bottom would show up. So instead of looking at a single time point and a dose response relationship, each one of these little individual views within the bottom display is a single dose level, and it lets me focus on what's happening over time. So here, for example, in the dog study, on the mid-dose group, I can see what happened on each one of the days, that it increased to a maximum at the end of the dosing phase, and then it decreased during the recovery phase. So both types of important relationships that I was hoping to focus on, either a dose response pattern or a time course, I can look at the same view. And again, I can look at summary data as well as individual subject values, and I can look at and see if there's any subject that appears to be very different from the rest of the subjects in the group. It will allow me to readily spot outliers. It will allow me to readily determine the sample size. I can see by the cloud of data points what the number of subjects were that were examined. I can click on an individual dot and it will show me that subject's values over the various time points. I can click on a group of subjects and then drill down on those subjects to see what else was going on for those subjects. Were there any other clinical observations that were of interest for those subjects? Were there any other lab measures that had a similar pattern? What happened to the histopathology data for those subjects? So I can always get from one plot to another to get additional subject data for these same subjects. Something that we're working on to release with our next version is the ability to overlay historical control ranges on these plots too. So you can see, is a trend that I see something that falls within a range that I would have seen in historical subjects, historical control subjects, or is this something that is really outside of that range that I would have seen in control subjects? Either of these plots can be saved as a publication quality SVG image, and then that can be embedded within a PowerPoint presentation. It can be embedded within a Word document or an email to be able to communicate findings with other scientists or people who are on your drug development team. This particular visualization is useful in numeric endpoints like body weight data, lab measures, and organ weight measures. This next plot is a single study visualization, and it is called a severity heat map. So this is used for macroscopic, microscopic, and tumor findings that aren't numeric in nature, but are more qualitative in nature. I identify the tissue, I identify a finding, and I identify a severity, and I want to be able to see patterns and trends, a dose-response relationship in the severity of those findings as we increase dose level or in the incidence of those findings or both. So in this display, I have the tissue names across the various rows. For each one of the tissues, I show all the data-driven combinations of finding, severity, and the finding. So I see unremarkable, I see various findings, and all the severities that were associated with that finding in this particular data set. And then there's a separation between tissues. So here I have bone marrow femur, followed by epididymis, etc. Each one of these sections is differentiated with this gray bar to separate those tissues out. In the columns, I have dose groups that are separated by a gray bar. So I have my control, my low, my mid, and my high dose groups. Within each one of these dose groups, the various columns are individual subjects in that group. Now, as we look at a given tissue and I move from left to right, I can see where the subjects had findings that were either unremarkable, the ones that are color-coded green, or the ones that had a remarkable finding where the severity is color-coded based on the scale from yellow to orange to pink to red, based on the increasing severity of those findings. And as I look left to right, I can see, is there an increase in either incidence or severity or both as I increase the dose level. In this particular visualization, I'm showing terminal SAC subjects next to recovery subjects, so I can easily pick out whether or not I see findings in terminal SAC subjects. Were those same findings seen to the same extent, to a lesser extent, or not at all in subjects that were allowed to continue in the study on the recovery phase? All right, so again, this allows me to see individual subjects. It lets me determine whether or not subjects had a tissue examined. So for example, in this particular tissue, I can see, and here's another one down here, I can see that there were subjects in the control and the high dose group that were examined, but I can see where subjects were not examined in the mid and the low dose groups. Here's also a tissue where I see there's a low incidence occurrence in the high dose group. I have none in the control group. I did not examine the low or the mid dose group, but I see a couple in the high dose group. So that may be something that's meaningful to me, even though it is in low occurrence. So you want to make sure that your visualization will pick up on that for findings that are not very frequently occurring. In this case, too, I can always drill down on an individual subject. If I see a subject that has interesting findings, I can just click on the subject number and then drill down and see what else was going on in that subject. Okay, that's a single study visualization for histopathology data, macroscopic, microscopic, and tumor findings, but one study at a time. On this next slide, I'm looking at a multi-study, multi-endpoint line graph. So if I'm examining this data, I have 3 different endpoints that I'm looking at: body weight data, body weight change from baseline data, and a lab measure, ALT. And then I'm looking at two different studies, study 123 and study INDS 11. Both are dog studies of the same duration, but I can see them side by side here now to compare these measures, not only within a study, males and females side by side here for each one of these studies, but I can also look between these two studies to see if the relationships, if the patterns are similar between these two studies. So multi-study and multi-endpoint line graph. Right now, I'm looking at group mean data, and the colors are in order that I would expect them to be: control, low, mid, and high dose group. So I can see if there's any kind of dose response relationship, but it's also possible for me in this visualization to drill down and look at individual subject data as well. So again, I have the ability to look at summary data, but I can also look at individual data points within that summary data to see if there's any subject that is influencing the value. In this particular visualization, I have emphasized the control group so I can have that stand out against the other groups to say these are the subjects that weren't treated, and let's compare that to the low, mid, and high dose groups. It allows me to identify outliers when I'm looking at the individual subject levels so I can pick out any subjects that were meaningful. And it also allows me to look and see if there's a pattern similar across endpoints. So not just one endpoint at a time. This too is a visualization that I can save as a high quality SVG image and include in a PowerPoint, a Word document, or in an email. Next up is a visualization that I call the histopathology bar chart. This allows me to select multiple studies. In this case of the example I have here, I've got two different studies for the same compound, a rat study and a dog study, and I've selected some tissues that are of interest. And then the bar chart will tell me the number of subjects that had a finding color-coded by the severity, the total number of subjects that had a finding out of the total number of subjects that were examined. So I can see if there's any kind of dose response relationship, control, low, mid, high within a tissue, but I'm also able to pick up on whether or not there's an increase in the severity of those findings. You'll notice that each one of these bars is labeled to identify the total of number of findings that were found for that particular group and that particular tissue, but it also has a denominator that highlights the number of tissues that were examined. So that is very meaningful because when we come to zero values, like in the thymus and in the kidney, I have a couple of groups, several groups that have zero findings that were observed. In the case of the thymus, 0, 0, 0, and control, low, and mid were all 0 out of some number of subjects that were examined, 30 tissues, 20 tissues, or 30 tissues that were examined. And so the 0 really means that I looked at those tissues and none were observed. Whereas in the kidney, for the low and the mid dose group, you can see I also have 0 findings that were observed, but it was out of 0 that were examined. So that's a very different meaning of the number 0 there. So the denominator is really important to include in those visualizations. When I'm comparing between these two studies, the rat and the dog study, I'm forcing the same y-axis so I can see the magnitude, how it differs, the magnitude of the number of subjects that had these findings and the severity with the same scale for both of those plots. I'm also able to use the same visualization to look at historical findings in control subjects. So rather than filtering for two different studies on the same compound, I would filter for just control subjects looking across all of my studies, and then I can look at background incidents in rats and in dogs and other species, the background incidents in subjects that are not treated by species. So it allows me to get that background incidence as well. So this is useful for dose response relationships and also for historical control comparisons. This visualization is called a historical control distribution plot. And for it, I am filtering the database for only subjects or only observations that were taken from control subjects. Here I've selected a single endpoint, cholesterol. I've got a plot for males on the top and females on the bottom, and I'm color coding by species. The blue bars or the colored bars represent the total number of observations of control measures that fell in a particular range of values. So this is basically a distribution histogram that tells me was the data, does it look like it's normally distributed? Does it look like it's skewed? Does the distribution look like it's the same between male and female subjects? And in the case of this particular endpoint that I've selected for the data that I had loaded into my Sen Explorer instance, it appears that the female distribution of cholesterol is shifted to the right versus the male distribution, at least in the rats. The blue color coding here refers to the rats. So it looks like the distribution is shifted in females versus the males. So here, my y-axis is different between these two plots because I'm purely trying to focus on the shape of the distribution, not on the actual counts. It's not so important for me to have those y-axes be the same between those two subplots. All right, so those were visualizations in Sen Explorer that kind of took to heart those guidelines that we were trying to look at from those questions that were posed earlier in this presentation. And I do want to remind you, when you're trying to look at your own visualizations and try to improve your visualizations, there are some pitfalls that you may want to avoid. A pitfall being the inability to detect dose-response relationships, especially when it's a rare event. So make sure your visualization can pick up on dose-response relationships. That's part of one of the most important relationships you're trying to identify in your data. So make sure it's able to do that even for rare events. Another thing you want to avoid is the pitfall of not being able to see individual subject values. You want to be able to pick up on subjects that are outliers because they may be really interesting subjects. And so you want to be able to look at those subjects, drill into them, and get as much information out of them as you can. Also, check out the character-based values that you have in your plots. Make sure that they're being sorted in a meaningful order. You don't want your dose groups to be out of order. You don't want your severity values to be out of order. You don't want your sacrifice dates to be out of order. You want those to be meaningful when you're looking at a plot and not have to do some sort of a relationships transformation in your head. Another pitfall to avoid is the inability to discern differences in the number of subjects that are examined or the number of tissues that are examined across groups. So you should be able to pick up on differences in sample sizes. Otherwise, it can affect how the data are interpreted. You want to avoid differing X or Y axis values across plots when it's important to the understanding of that data. So there are cases when it isn't important, but when you're trying to make meaningful comparisons in time or in values that where the relationship should be the same, like two different studies with the same species, then you would want to make sure that your axes align between those plots. Another thing to avoid is axes that change unexpectedly. So if you're looking at summary data and then you're drilling down to subject data, you don't want the axis to all of a sudden change on you. And now I can't put into perspective what happened to the subject versus what was going on in the overall group. And finally, pitfalls to avoid are pie charts or donut charts that have lots of different segments that may obscure relevant relationships or maybe make it hard to tell what's going on within a study with looking at dose-response relationships or even time trends. So if there's a pie chart that's very busy, it may make it hard to understand relevant relationships. So I would challenge you to take a look at your visualizations with these things in mind. Try to improve your visualizations in order to take advantage of some of these tips and tricks that will get your visualizations to be optimal for your data. We actually have a number of webinars that are focused on getting the most out of your Sen data. This was the first in that series, but we will also be doing future webinars on performing QC on SEND data sets. And then we'll have a webinar devoted to looking at single study visualizations when you're trying to monitor an ongoing study. What kind of visualizations would you want to use for that? We'll focus another webinar on multi-study visualizations when you're trying to compare studies within a program. We'll look at leveraging historical control data for your visualizations and also how you can use interactive scientific data review in understanding patterns and trends in your data. So we kind of saw a few of those things in the examples that I was giving at the second part of this talk, but in those future webinars, we'll be able to spend more time on those and I'll give you some thoughts on how to get the most out of your SEND data. All right, at this time, I'm happy to take any of questions that you might have.
Thank you, Joyce, for that great presentation. If you have not already done so, please enter any questions you may have in the chat, and we'll answer as many as we can. Joyce, I'm going to go ahead and read some out to you. We already got a few up here. Okay, so here we go. If you can identify some pros and cons of using a general purpose application like Excel versus a third-party application for SEND visualizations.
Okay, all right. So I agree that there's kind of two general classifications for data visualization tools. One of them is like a general purpose tool. A general purpose tool meaning that it's used for any kind of data. It could be data from financial data, scientific data, manufacturing data. The tool itself isn't focused on the type of data. And those would include things like Excel, Spotfire, Tableau, Business Objects, Power BI, lots of generalized tools. The advantages of that sort of product is that an organization may have ready access to that kind of tool. They may have internal expertise in that kind of tool, and they may have lots of interest in using that type of tool because scientists are using it for other products. And they also tend to give users more flexibility in customization, so they may be more likely to allow you to tweak with the colors or with the font size or with the symbols and things that are used. So that tends to be an advantage of those kind of general purpose products. You don't have to have, they're useful for many visualization types, many data types, including SEND data. On the other hand, we have more specialized tools that are often built by a third party, but wouldn't have to be. And those would be things that are like built to deal with a specific data type like SEND or SDTM. And the advantage of that type of data is that you can actually kind of establish an ecosystem around the particular data type. So you know what the business logic is, you know what kind of nuances you want to be able to deal with. So if you're dealing with a specific type of data, then you can build the visualizations kind of to address that. The other thing is that like a general purpose application may have some built-in templates. They have templates for lots of different different ways to look at line graph or scatter plots, but you really have to stay within the framework that general purpose application is providing you. There's no real way to apply nuances that may be specific to the type of data that you're looking at on SEND or SDTM. So you have complete control in one of these, the developers have complete control in one of these third-party applications are developed especially in-house to do that. And the best example I can think of that is with respect to a line graph. If you think any visualization tool can produce a line graph, but something that we've purposely built in is that the line graph on the x-axis, which is looking at time, on the x-axis, you can flag the dosing time points. So now I can put the line graph into perspective of when the subject was treated and when it was not treated. So that's definitely an advantage. The con is one of the advantages of the other product, and that is that you have less control. An organization has less control when you're getting something that's developed by a third party or purpose built.
Excellent, thanks. So we have another question here. How can you tell if your visualization obscures low incident findings?
All right, that's a good question too, because you don't know what you don't know, right? If you're looking at your visualizations and you say, how do I know if it's obscuring a low incidence finding? So I think the best way to test this out would be to come up with a SEND data set that you know, for a study where you know this is an issue, right? Or mock one up. So you say, let's put a couple in the high dose group and none in the control, or one and several. Are we able to pick up on those low incidence? So you kind of have to know of a study so you can see if your visualization handles this properly, or you have to be able to mock up one. Now, I will say that there is a really good publicly available data set that you probably heard of called PDS 2014, and it was anonymized many years ago and published by PDS. And I know we found that extremely helpful because it's all anonymized and uses some real, some made up data. So I think it's a good one to test with. And I believe, is my recollection, that in that particular study, PDS 2014, there's the tongue. I know the tongue has a kind of a high incident, a low incidence, high dose effect. And there's two others, bone marrow, sternum, and pancreas. I think those are three tissues in that particular data set that you can use to see if your visualization will pick up on those low incidence but meaningful dose response relationships. Actually, I don't know if they're meaningful or not. I'm not a toxicologist, but it looks from a statistician's point of view that those may be of interest. And I would recommend that you either mock one up, use one that you know internally, your own data that has a low incidence finding, or try that PDS 2014.
Okay.
Yeah, good question.
Next question is, are there any visualizations that can help identify underlying issues with the data?
Okay, so as far as visualizations go, I think I mentioned this earlier, that if you look at a plot that has both summary and individual data points in it, that will help you detect outliers. And sometimes the outliers are actually data errors. So if you can kind of see what's going on, especially if you can look across groups, not just one subject at a time, but all the subjects within a group, and then maybe put males and females side by side so you can distinguish those. But then you can see, is there an outlier? Is it really a data issue, or is it a legitimate data outlier? Another thing is, I know we have I call it a visualization, but it's really just a view, a hierarchical view, and we call it the schedule view, that allows you to put all of to select a domain and then see all of the time points on which measures from that domain were collected. And also in that PDS 2014 study, it has some outliers and there's some unusual data points in the food consumption domain. So if you were to load that one and do a line graph or go to this schedule type view, you would see that there's one or two endpoints that are in the food consumption domain that are out way past the end of the study. So that it just like, whoa, there's something going on there, that all the rest of the endpoints are within 4 weeks time, and then this one is way out in the hinterland. So that is a good way to see outliers if you do plot it, if something looks unusual. So PDS 2014 might be good to help you to look at, does your plot help you find that? But some sort of a schedule view. And I think that 2014 is also the one study that has a one endpoint, alb-glob or albumin, I forget which one, alb-glob. That same endpoint appears in multiple dose categories. So it appears under hematology and appears under urinalysis and appears under clin-chem. So if there's something unusual going on like that, a schedule view or something that will allow you to pick up on those kind of oddities, would be very, very helpful. You also want to know, are there any endpoints that are missing? Are there any unexpected values that you weren't, or endpoints that you wouldn't have expected to see there? Of something that's really a low count. Why is it such a low count? So applying systematic QC to your data, looking at summary measures, comparing that to a study report, that will certainly help you to find issues. And summary views that have a tabular summary view will help you to detect those outliers. We just mentioned that we have other of these sessions, and that QC webinar is coming up using a tool to do a QC of SEND data sets, is coming up as the next webinar. But it is helpful to have some mechanism while you're viewing your data, visualizing your data, to see if there's problems with it. So yeah, good question.